Hi, this is Joe Bolen, and today we're going to look at iteration coding patterns in Visual Basic. Now that sounds very fancy, iteration coding patterns, but basically we're looking at repeating code over and over again, what we call loops. It's sort of like getting caught in that old movie called Groundhog's Day, where you keep repeating the same day over and over and over again until you get it right. But for us in coding, that's a very good thing because it allows us to do things that we need to do a number of times until we get our task completed and then leave our loop to go on and do other things. So let's take a look at what iteration in Visual Basic is all about. So I have on the screen, basically I'd like to bring to your attention, it's a repetition of statements. We call it looping or loops on that, but basically we're going through and doing things over and over again. Now there's some dangers with doing that. You can get stuck in a continuous loop and can't get out of it. But we're going to teach you how to get out of that loop and use it efficiently. Now there are in Visual Basic different types of loops that we have, and the first one is the very basic do loop, and also potentially one of the most dangerous ones, because basically we're saying do something, keep doing it, and loop around, keep doing it, keep looping around and doing it. And unless we code something in the middle to say stop doing it and get out of this loop, we're stuck there. So this is a nice one, very simple. It's the basic of all the other loops, but it can be the most dangerous one to code with. The next one is the do loop while. And with the do loop while kind of coding, we'll go into the loop, do some code, and then we're going to, at the bottom of the loop, check to see if we've satisfied a condition that we've set. Now the danger, once again, is if I didn't set a condition to be satisfied, or if that condition can never be satisfied, I'm stuck in a continuous loop. So we're going to always go into the loop once, process what's ever inside our loop, and then test at the end of the loop whether we've satisfied a condition. And this is what's called a post-test type of loop. Another post-test type of loop is a do loop until. Here we're going to always go into the loop, perform whatever's inside our loop, and then when we get to the bottom of our loop, we're going to examine, are we still with a condition that's true? If we are, we're going to go back in and repeat the loop. Once the condition ceases to be true, then we'll exit the loop. But with both the do loop while and the do loop until, we're always going to go into the loop at least once before we exit. And we test our loop at the very end to see if we've met the conditions to leave the loop. Another loop of the 7 we have is the do while loop. And in this case, what we're going to do is test the condition first, do while our condition is true. Then we're going to go in and do the statements inside the loop, and then loop around and once again check to see if the condition is still true. This is what's called a pre-test kind of loop, because we will not execute the loop at all if our condition is not true going into it. So this one tests first, then performs the loop. Otherwise, it never goes into it. Another one just like it is the loop until loop, and this once again is a pre-test loop, and the difference is the way we condition it. Do until this is true, we're going to loop around. A lot of times we use this one for looping on a reading of a file. We do a do until end of file condition, and we keep looping till we get to the end of the file, and then we'll leave the loop. So both the do while and the do until types of loops are pre-test loops, and for me, our preferred way to code. Then we come to the one we use a lot of times is the for next loop. And here we actually set a counter that we're going to use to monitor our loop. And And the process of going through the loop, we're going to increment the counter by whatever step we decide with, and we'll keep looping for a certain number of times. So if we want to do it for 4 times, we'll do it for just 4 times. We can leave it early, but normally we'll do it for the number of times we've set it to run on this. Now, the thing about the for next loop is that we have to know how many times we want to do something. We can't just go into it waiting for some condition to be satisfied like the above conditions. This one requires us to know how many times we're going to be doing it. And then the last one, which is the one we'll use a lot as well in programming, is the for each loop. And here's where we look at a collection of something, and we say for basically every element or item in something, we're going to keep doing it until we go through all the different elements of our collection. So this one, I do not need to know the counter. I just know that I will go through it a number of times that I have of elements in my collection. And this one is very good for arrays as well as the for next loop. And we'll take a look at that in our code. So here are 7 different types of iteration: the do loop, the do loop while, the do loop until, both post-test, and the do while loop and the do until loop, the pre-test, the for next, and the for each next. We'll take a look at those in our code now and learn how to use them. So I'm going to go back to one of our simple programs with a one-dimensional array, and we'll use that one-dimensional array to see how we iterate through those. So this is my basic form with a list box that's read-only, and we'll code against the display buttons click event to run the code. So let's first of all take a look at our code that we have behind this one. Okay, I have, as we come into this one, I want to bring to your attention first of all that the documentation for this program is out on the internet, and you can go out and look at the screen capture of the program in Imager, and also the code that you see that I'll be working with is at Pastebin, and of course this presentation is at Bolen Presents at YouTube. So if at any time you want to stop the video at this point and write down this information so you can go out and take a look at it, please do so. Also, there's a link off of the Bolen Presents site to go to Pastebin directly to see the different codes that I have out there. Okay, let's take a look at our code itself. As we come into our code, I've set on option strict, and I have inside here a class level set of variables that we'll talk about in just a minute. But here's where we left off with our last program, which was one-dimensional arrays, where we went in to our array, we declared its size, and then we initialized each element one by one, putting in and referencing the elements by their individual indexes. Well, we're going to change that a little bit in this program, so I'm going to take this particular part of the code out. So I'm going to knock out this section of code here and delete it out. And then I'm going to come up here to my class level variables where I'm going to declare that array again. This time I'm going to declare it and initialize it in one statement. And also I have 2 other variables that I'm going to be using in this exercise at the class level, which makes this available throughout the whole class of this particular form. So I'm going to have an index that I'll use throughout some of our loops. And then also, just for an example, I'll have a variable called sum total that I will collect or accumulate the sum of the values in each of the elements of our array. So here is our array with its values, and we'll go looping through the array to see the values and to collect the total. Then let's come down here to the code that I had from the last video where we actually printed out the lines, and you can see there it's quite redundant except for the index change that appears here. Well, we're going to change that in our code, and I'm going to take this part out now, and we will do it a little bit differently. So let me wipe this part out, And I'll keep the code right there above it in place, but I'll knock out that. And let's take a look at iteration area here. And I've got it set up for a to-do iterate. I've put in my first loop. And here is where I'm doing a do loop, just a straight do loop. The first part is just to initialize and put in the list box the information about what I'm going to be doing. And so I'm doing the items add to the list box. And then we come to the meat and potatoes of the actual do loop. First of all, I've set an index at 0, and I've zeroed out also the total before I begin the process. Now here is our simple do loop. No conditions around it. And here I'm adding to the items property of the list box the value of the index and also the actual value of the element in that array at that particular point in time. So coming in, our first element in our array is 0 element, the first one, and then I'm going to take the value of that first element and add it to the sum total. And I've used the shortcut method of plus equal. This could be written as sum total equals sum total plus my array in parentheses index. And then I've added 1 to the index on this. Now this is a very important thing to do. We increment the index for the next time around, but the important thing after it is if the index now becomes greater than the number of elements I have, and then we use the get upper bound on the first rank, which is the 0 rank for a one-dimensional array, we're going to say, okay, if I reach the upper bounds of my limit, if so, then I need to exit out. Without this line in there and without incrementing the index, I would keep going on and on and on doing this, and I'd actually have to stop the program by ending the program with killing the task. You have to always code in some kind of condition to exit out, and here we exit out with an exit do statement to get out of our loop. So let's watch this one run, and it'll run through our array. Okay, we've got it compiled. Let's hit the display button, and there it goes through, and we're very quickly through the do loop, going through, referencing each element in the array till we got to the 6th element in our index, which exceeded our upper bounds, and then we exited the loop. So here are the values in each of the elements of the array, as well as the index. The important thing to remember when we're working with a do loop is we have to have some kind of condition to end the loop on that. So remember, if you're using a do loop, you've got to have some kind of condition that will be satisfied to exit the loop. Okay, let's take a look at another one. Let's go back to where I have some pre-done loops, and we'll take a look at the next type of loop, and this is the do loop on that. I'm going to copy this one back over to our code, replace the one we have here on that. Okay, now let's take a look at this one. This is a do loop while, and this one is a post-test or a post-test type of loop where I always come into it once. So coming into it, I'll have index 0 like I did with the first example on that. I'll increment the index, and here I have the condition statement while the index is less than or equal to my upper bounds value. In this case, we're going to go through till I exceed 7, and once I exceed 7, I'm going to leave the loop because this condition will no longer be true. So let's run this one. Okay, let me make it a little bit bigger for you and hit this one. Once again, it runs very quickly through on it. And the important thing to remember as we go through this is that we do the post test and set some kind of condition for the post test. So here we see that post test has to be in place, and I have to have it so that some condition will be satisfied. Now, if I miscode this and have the wrong kind of relationship, I'll get stuck in an endless loop. So monitor that as well. Let's do a little bit of addition of the sums to get the sum for what we're doing here. So I'm going to uncomment this line here. And we'll see now that as I collect the sum total, I'll then print it out as our last line in our run. Let's take a look now at another kind of iteration example. And this time we'll go to do the do loop until. And I'll replace this one out. And once again, very similar. The difference is the condition here is different. If I use the same one that I had before, I'd get stuck in an endless loop. So when I can code for a do loop until, what I'm looking for is to do this till this condition is satisfied. So up to this point, as I go through each time, the condition will not be satisfied as I increment until I get past the number of elements I have. Once I get past the number of elements I have, I'll continue on to the next line. Let's run this one. Okay, and here we go. And here also we see doing this process very similar as the other one. And now I've added the sum statement afterwards, so we see the sum of all these being printed out as I add them one at a time through the loop. Okay, so the important thing here is to remember that the do loop until and the do loop while need a condition to be satisfied for them to keep running around doing their process. Once they meet this condition that's been set, then it'll leave the loop. So we have to make certain that we're taking care of, in this case, an index that we're wanting to monitor, and we're going to check to make certain we haven't exceeded the upper bounds. Otherwise, we're going to throw an error exceeding the range of the array. Let's take a look at another kind of loop on that. We're going to use the do while, which I particularly like the best, and I end up using the most on that. So let me bring this one over and replace it with what we have here. And this one, I can check the condition before I even start. So if for some reason my index was already higher than my upper bounds, I would never even enter in the loop. In this case, though, I do have to remember to increment the index so that eventually when I come back up here and test, I'll have a different value to look against. So coming in, it starts at 0, which means that it is smaller than my upper bounds of 7, or in this case, it'd be upper bounds of 6, and because we have 7 elements. And we'll keep going through, adding to our sum total, incrementing our index till we get to 7. At that point, the condition is no longer true, and we exit and come to the next line. Let's watch this one run. Okay. And here we see it go through and also do the exact same thing on that. The difference is we're testing before we enter in to see it run. Okay, let's take a look at the next one, which is a do until. I'll grab this out, put it into our code. And in this one, we're going to, once again, look at this condition, do until this condition is satisfied. In this case, we're looking to the index getting too large, greater than 6, and we'll see that run. Okay, let's run this. Okay, and there we go. Okay. Now, I'm going to put this in break mode so we can actually see this process going through. So I'm going to set the break mode right here at line 68. And then I'm going to run it and debug, and we'll actually step through and watch these values change. So I'm going to hit start, and then I'm going to hit the display here, and I'm going to move this over so we can see it a little bit. In fact, I'm going to get it just off center so we can see everything. Hit display. We're coming in, our index is going to be set to 0, and I'm going to step into with F8, set the sum total. Now we begin our first one. And our index right now is 0, and our upper bounds a value that we'll see in a second. And our upper bounds comes in, and we're able to process the first one. We keep going through. We'll see it loop, hit the index. Now our index is now 1. We're going to come back up, loop through, come up, loop through. Okay, let me take a look at where we are with our index at this point. It's now 4. Now it should be 5. Let's keep going. It's now 6. And it leaves the condition and continues on out. So we can see and watch to make certain it's running correctly. So if you have a problem with coding your loops, remember, put it in debug mode by setting a breakpoint to the side and step through and watch your index change to make certain it's changing the way you expect it to change. Okay, let's take a look at another one. I'm going to take that out. Let's go back in. And now let's take a look at one of the ones we use a lot. And this is a for next kind of loop. I'm going to copy this one into place. And I want to take a little time to talk about this one because we use it a lot as well in coding patterns. And here's where I already know how many times I'm going to do this one. In this case, I'm going to use the length of the array. This will give me the number of elements that I have. And remember, we start at base 0 in our elements, so I always want to go back one level, back one element in my length statement. Start at 0 to the length minus 1, and here we see the step 1 in here. Step 1 says how much I'm going to increment each time I go through. Now I've declared IDX as an integer. Now I could declare that the IDX or some other variable somewhere else, but you can code it right in your line to declare it. Here, so we have the index as an integer. I'm starting at 0, and I'm going to go till I get to the total number of elements I have in my array, minus 1. And then I'm going to step it each time I do it. When I hit the next, I'll step it up one more time. Now, the step statement is not needed if it's just a step 1. That's a default. So I could take this out, which I will on that. And I'm going to also put in the breaking here so we can see this change as we go through. So let's start this one in break mode. Okay, I've got this coded, and we'll see this come in. Index will get initialized in our next statement as we hit the display and come into our code right now. So I hit the step into, and at this point index is 0 because it started with 0, and our length is 6. So remember, we're going to go from 0 to 6 on that. And as it processes, we'll see this one print out the first line. And I'll bring back up the box so you can see the first line is there in a minute. Then we're going to go around again. At this point right now, our element we're working with is 2. And right now we are working with element 5. Now it's element 6 getting ready to come up. At that point, 6 has exceeded our length on that, and we're now ready to pop on out and come down and finish out our program. And we'll see that we populated it through just like we did with the other kind of do loop, but we already knew how many times we were going to go through and process this. Now let me change this a little bit, and let's go back into the program. Remember the step statement defaults to 1, but what if I change it to step 2, which means I'll do every other one. Let's run this one. And I'm going to take off the brake mode so we can go faster on this one. And we should see it only occur 3 times. And there it went through 3 times, and we saw only elements 0, 2, and 4 on that. If I wanted to see elements 1, 3, and 5, I'd change my beginning index. And I'll show you that. I could change that to start the first one, do a step 2, run this. And here we'd see elements 1, 3, and 5. So we can change our stepping value. If I want to do every third one, I'll go back to 0 for this one and run it. And here we'll see it do the 0, 3. That's all it can do, and it exits out. So we can change the step statement to how we want it to run. And we can change our beginning value and our ending value, and we have to declare a index that we're going to use, or I should say this is a counter, but in this case our counter is going to be used as the index to our array, so I called it index for this one. Okay, let's look at another example. The 4 next is used a lot. Let's take a look at it. Instead of using the length statement, let's use the upper bounds, which is a better way to code for an array. Because the length statement represents all the elements of all the ranks of the array. Now it's fine for a one-dimensional array, but for a multi-dimensional array that could give us some trouble. Okay, here we're using the same thing, but we're using the get upper bound of the first rank. In this case, we always start with the subscript 0 on that. So we're going to go do this number of times of elements we have in our array. Let's watch this one run. And I'll do this real quickly, and we'll see this one gives us the same results as before. Once again, the important thing here is we're using the get upper bound, not the length. You'll see sometimes programmers on one-dimensional arrays use the length statement -1. I recommend you use the get upper bound. This one is less confusing and guarantees you'll stay within the right rank that you're working with, and also you won't exceed your limit of your array. So use the 4 next kind of coding when you know how many times you're going to go through it. In this case, we do know because we can determine it by using the get upper bounds for the array that we're working with. So, but if you knew exactly how many times you wanted to do something, this would be an ideal method to use. Okay, let's look at a situation where we don't know how many times we're going to do it, and that's using, well, let me, I got another example here. I'm going to use this one with a sort, and this is to tell you a little bit more about arrays in general. I'm going to copy this one over, and we'll see this one, and this one does just a little bit different. It's the same one we had before on that, but I'm going to do a for each on this one, and I'm going to add into it the condition of sorting. So here we see array sort, and this sorts the array, all the elements in the array ascendingly, or from smallest to largest on that. So we'll see that change as we loop through. Also, because we do not need to worry about the index itself, we're just saying for each value, and the value in this case is a double data type for array in array. So the coding for the for each is much different. We're saying for each basically element in the array, we want to add the value to the list box, and also sum the value for sum total that will printout down below. So I do not reference the actual index with the for each statement. I reference the values in it. So let's see this one run. And here we go. Now we see a little bit different. Instead of having the writing out with the index, which I don't have in this case, I've sorted it from smallest to largest with the array sort command here. And then I'm going through and processing each element in the collection on that with the for each statement. And then once I process this out, then I'm going to come down to the next line where I have my total line. So this one's nice when we do not know how many we're going to be processing. We're just saying we're going to want to process all those in the collection. In this case, the collection is an array that we're working with. Okay, let's take a look back. And let's take a look at using the for each next statement again. But I'm going to do a little bit something different with the array itself. Let me come back up here. I think I missed a little bit of it's a comment line. Okay, let me come back to this. Put a comment in there. There we go. So what we're going to do this time is not only sort it, then I'm going to reverse my sort, and now it'll actually be making it from the largest to the smallest. But there is no quick way to do it. We have to first sort it to make it ascending, then we reverse our array. And now I'm going to use the same concept of the for each statement in this one. The important thing here is the switch of the array sort and array reverse to get it my array in a different order. Okay, and we'll see this one. And here we go from largest to smallest. It first sorted it from with the array sort. It went from small to large. Then we flipped it around with the reverse and went from large to small. And then we processed this output with the for each statement. And the last one I'd like to show you, and this is just for fun, but it'll give you an idea of some of the power of LINQ, which is language integrated query. I'm going to pop this over and copy this. And this one I'm going to add to the one we just did on that, and I'm going to put it in right here afterwards. And LINQ does a nice thing that we can use as well, and it allows me to quickly find out the values of the minimum, maximum, and sum and average very quickly in my processing on that. So we'll get to see this one. In fact, the sum is the same as the total, so I'll comment this one out. And we'll see this one run with LINQ using its statement. And this is just for fun to give you an idea of how powerful this can be. And also, if you're working with an array and you need to get the minimum, maximum, sum, this is how it's done. The array dot minimum or dot maximum, and then the toString method to process it out. Okay. Let me move this over a little bit. Now remember, we're reversing it, making ascending and then reversing the array. Then we're looping through the for each. Then we're using our LINQ to get the minimum, maximum, sum for this one. So let's run this one. And here we see it running. And we've processed out the information we had from the last example. Then we used LINQ, and it quickly gave us the minimum, maximum, sum, and average on that. Now, the one thing nice about using LINQ on an array is we can get these kinds of things that are not normally available to us when we're processing an array. We can do it other ways. The old-fashioned way would be just to collect all the values and then divide it by the number of elements we have if we wanted the average. The sum you saw as I was doing the total processing. We had to loop through and actually put a value into a accumulator field called sum total. But we can do that very quickly just with using link. So these are some of the other additional things that Visual Basic offers to us when we're working with one-dimensional arrays and multi-dimensional arrays. And the important thing to remember is arrays are very powerful to store like collections. And once we have collections, we want to iterate through our different collections that we have. And if we use link, we can take advantage of its commands to give us further information and process very quickly some of the things that we might want to have show up as we work with our code. So I'd like you to get your hands dirty in the code, go out to Pastebin and pull in the code. And if you want to see the screen capture again, go out to Imager and see it as well. All that will be documented inside the code at Pastebin. And you'll see also my little templates to the side showing you the array loading, the iteration examples, and so you can keep repeating and trying out different things. And just to give you a little fun to this last one, I'm going to take all the different iteration examples and paste it into our code, and you'll see the list box fill up with all of it, and that'll give you also an idea of the power of the list box. So let's do that as our last thing before we close out. Okay, I'm going to go over and go to my examples. In this case, I'm going to just grab the whole thing. So I'm going to do a Control-All, copy. I'm going to come over to my form, and I'm going to take all this through here and paste it in right at this point. And so we'll have everything in there, and let's run it all. And I'm going to make it so we can see it. And with all those different iteration examples, I'll hit the display button, and they all fill up, and we'll see it doing a do loop, a do loop while, a do loop until, a do loop, do while loop, a do until loop, and then we'll see down below doing a for next on that, and then we'll see our sorting with the each, and then our last one where we reverse the array using the for each statement, and then our link statements at the bottom. So you can see all of them at one time in our list box, which once again is a collection that we can use to iterate through as well to see the statements in our collection. So we've seen in the last couple of videos how to use a list box, how to code for a one-dimensional array, and we've seen now how to iterate through the different elements of an array. So have fun, get your hands dirty in the code, learn about this looping iteration process so that you can take advantage of doing things that have to be done over and over again till some condition is met. Now remember, if you never meet the condition by miscoding something, you're going to be caught in an endless loop, and you're going to have to kill the program to get control over it again. So take a look, run it in break mode to check to make certain it's working the way you expect it to work. Check your logic, but try it out and get your hands dirty in the code. And until next time, take care.